So we will go through some of the advanced SQL concepts which is highly used in the our day-to-day life as a data analyst or data engineer or as a SQL developer. So just a minute. So these are the concepts I have mentioned over here, which is used on a mostly on daily basis. So let me. These are the window functions. We can say that window functions with aggregate with the combination of aggregate functions, then recursive queries. You can say that as a recursive CTE, then subquery, correlated subqueries, ranking functions. You can say that self join and subquery in the from close as well as advanced analytical functions. So this will be our main agenda for today's session. So you can ask the question whenever you have any doubt. So I hope you have some basic knowledge in SQL. So just let me directly start with the topics over here. So over here I have created this sales data table. Let me show you first the table data. So if you see over here, this is a table data is there. This is a very small table I have taken for the sample. So let me copy this data into the Excel file. Now over here, our objective is we need to do the sum based upon the category, right? Sum based upon the category, each of the category. So if you see over here, so over here only two distinct categories are there, right? Let me, if you, two distinct categories are there, category 1 and category 2. So can anyone tell me what will be the sum over here for category 1?
It's 3,000.
Yes, right, it is 3000, right? So 3000 will be placed over here. And what will be the output over here in the second row? We want to display the output in the each of the row wherever the category ID is same, right? Wherever the or category name, this is a category name is same. So over here it should be also 3000, right?
3,000. Again, it is 3,000 as it is
And
category 1.
in category 2, what will be the sum? It is 4000, right? These two value we need to do summation, and same will be replicate over here as well. So over here we are doing the summation for each partition by each category wise, you can say that, or group by each category wise, and we will carry forward the same sum for each of the row wherever category name is same. So that is the purpose over here. So let me, so for that we have used the sum of sales over partition by category, right? Because whenever the category will be changed, at that time sum will also be changed, right? So let me show you the result over here. So this is the same result will appear as in the Excel file, right? 3400. So this can be achieved in through group by close as well. But can anyone tell me now what is the drawback when we use the same in group by close? This is mainly we can say that category wise sum, right? Category wise sum of sales. But the problem when we use the group by is Group by will eliminate the group by will combine the data as per the group only, right? It will not show us each of the records, right? So let me show you the same. Let me run this both of this query. So if you see over here, it has done the grouping based upon the category 1 and category 2, but it is not showing the distinct sum, sorry, distinct sales for each of the row, that how much sales is showing for category 1 and category 2. It has eliminated this column. And now suppose if we write this column over here, suppose let me write sales, then this will give error, right? We need to add sales in the group by also, right? Because sales column is invalid in the select list because it is not contained in either aggregate function or the group by clause. So whenever we mention any column in the select statement, whenever group by is used, at that time either it should be a aggregate column, we have need to do some kind of aggregation over here, or it should be mentioned in the group by clause. So over here aggregation we have already done over here, right? So this thing we need to mention in the group by clause. This thing we need to mention in the group by clause. But now, will it be showing the correct data? That is the question. So let me show you. It is not showing the correct data as per the below, right? You are getting the things why we have used the sum of sales over partition by clause instead of group by. That I want to show you over here. Are you so over here I am explaining this one. 1 minute. Our requirement is we want the category wise sum against each of the category, and the sum should be replicated to each of the row wherever the category is same. So we are here, our the for category 1 the sum is over here 3000, right? So it 3000 should be replicated to each of the row wherever category is 1. So over here category 1 is in 2 rows, right? So 3000 will be there in both of these row. Then when the category is changing, the sum will mostly changes, right? So we need to do sum of the sum whenever category is 2. So what is the sum over here? It is 4000, right? So 4000 should be replicated to each of the row wherever category is 2. Now, can anyone tell me what this same thing will be achieved through the group by also, right? But what is the problem when we will use the group by? Can anyone tell me that?
We are using category sales also, right? That category one and sales. Again, we have to write that in group by also. That's the
Yeah, that is right. So let me show you the result. 1 minute. Okay, let me run this both of this query. So if you see our category 1 is 3000, right? That is correct. And category 2 4000, that is also correct. But sometimes in our data analysis requirement, we do not need to eliminate any of the row, right? Because of grouping, this has eliminated the rows as well as column, right? So our requirement is we do not need to eliminate any of the column or any of the row. So all four row is should be showing in our result set. But whenever we try to do that, so suppose we want to include cells over here, right? So will this work or not?
No, we have to use group by sales also in group by it will show some kind of
Okay,
error.
okay, right, correct. It will show some error over here because cells is invalid in the select list because it is not contained in either the aggregate function or the group by clause, right? So either we need to specify aggregate function again with this column, or we need to do the group by cells. But now, can anyone tell me both of these query will give the same result or not?
No.
Both will give same results.
Mm,
Mm,
no different result. Yeah.
No, will
yeah,
Yeah,
not
yeah,
give the
it will be
same.
different.
yes, right. It is giving different result, and actually it is giving first query will give wrong result. So see over here, our requirement is we want 3000 in first two row, but it is giving the same thing over here, 1000 and 1500. Why? Because it is doing the grouping based upon category and sales, right? And both of these category and sales is distinct in both the row, so it will give unique value of sales in category 1. And again over here, the category 1 it is giving same thing 2000, right? But our requirement is 3000 over here, 3000 over here. So in this particular kind of scenario, we cannot use the group by cannot be used in this particular case. In this case we must need to use some of sales over close only, right? Because group by will eliminate the rows as well as columns, right? Either it will eliminate the rows or either it will eliminate the columns or it will not give the proper result. So this query is clear, right? You can ask any question if you have any doubt, or in place of some over here, is there any option or is there any different way through which we can achieve that also you can tell. Let me, is there any different way we can achieve the same below result in the above query? Is it possible? Okay, let me try one other way. Select star from, I am writing this inside the st. Now category, then you can write inner join, then we can write sales, and then we can write total sales on sales data dot category equal to t dot category. Now let me try to run both of these query. Now see, I have achieved the same thing, right? But with different way. Have you got this thing? Now the result is correct, right?
Yes.
In above query and in below query, both the queries result is same, right? Now how I have used that thing? Over here, it is showing 3000 and 4000 against category 1 and category 2, right? But I want each each of the four rows and each of the column, right? But if I mention sales column over here, it is giving me wrong result. So I have used the other way around. And what I have done, I have mentioned this query as one table. So whenever you write this query in and you use as a inner join in some other query, then this will become one table, right? So over here T is what? Over here T is one table name, or you can say it as a table. Now I know I need to use this table as a main table, right? So what I have done over here, I have taken the category from this table. So all the columns from this table, right? All the columns from this inner table we can use in the outer table over here. So this is one column, right? Now sum of sales. So total sales is now one column in this T table, right? Total sales is now one column in T table. So that column I will directly use over here. So now T is one alias, or you can say that as a table. So T dot total sales. Now T dot category I have used. And now what other column is pending? I want sales also, right? So sales is not available in my this inner table. Sales is not available in this inner query as a column. So I have used that column from the original table. And I know that category will be same, right? In the sales data category. So let me select star from this one. This category should be joined with this category, right? So over here, if I write over here, then category 1 will be joined with category 1. Again category 1 will be joined with category 1. And then category 2 will be joined with category 2, and again category 2 will be joined with category 2. So it will give me 4 records only, right? Not the 2 records. And it is giving me the same result in both the queries. So now you can ask me if you have any question. But this is the beauty of SQL, you can say, because one thing we can do with multiple ways, right? One result set we can achieve with multiple queries, and that is the main beauty of SQL, you can say. Now you can tell me if you have any doubt in any of these two queries.
Harshit, if we use join instead of inner join, what could be the result? Can we try that?
Yeah, actually, this join, right?
Yeah.
Yeah, actually, this is the same thing, because whenever you do not specify any keyword while using join, by default it is a inner join only. And if you specify keyword, then it is then also fine, but if you do not specify, then it is inner join only.
Okay.
And over here if you use left join, does the result will be affect or not? Can anyone tell that? In place of inner join I have used the left join. Does the result will be different or same?
I think same.
I think same.
Yes, right. Absolutely, it is same only, right? Because
Hmm.
category 1 and category 2 only is there in this table, also in inner query, right? Inner query also we have used the same table. So result set will be the same only, right? Okay, now let me jump to the next query, which is a recursive query, or you can say that a recursive CTE. So let me show you this data. Select star from this particular table name. Okay, let me copy this data into the Excel file. Okay, now if you see over here, I have an employees table 65, and in this employee ID is a primary key, then employee name, manager ID, in foreign key I have created foreign key is manager ID, reference is same table, employee ID, right? So this manager ID is a foreign key. Now I have inserted the data into the same. Now our requirement is what? Now our requirement is I want over here only three rows are there, right? Sorry, three columns are there, right? But I want the level of each of the employee. You can say that level of each of the employee and manager name. Two additional columns I want. Level and manager name. Right? So for that purpose, I have used the recursive city. So now in the recursive city, you can say that the first, this will be the first part of the city, right? Recursive city. Sorry, this will be the first part of the recursive city. So over here, what I have done. So if you see in this query, wherever can anyone tell me which is the super manager over here? Super manager means all of the managers manager, or you can say that higher level manager. Who is that?
I think Janvi.
Jan.
Yes, right. So this what will be the level of this one? 1, 2, 3, 4, 5, 6. What will be the level?
Maybe she should be
One.
the one.
One.
Yes, right. And what is the manager name of her? It is null, right? Because she is the super manager, right? And her manager ID is null. So what I have done over here? I have done over here select employee ID, employee name, manager ID. By default, I have declared the one as a level and cast of null as a manager name. So this is my super manager. You can say that, or you can write over here. mm, Let me try that one. Super manager. Okay, because her its manager ID is null, right? Now, what is this consider as a in recursivity? This is known as anchor member, and this is a part one, right? Part one anchor member, and this is known as a recursive member. and this is, you can say that as a part 2, and this is known as a, you can say that recursive query or part 3. So recursive CTE will be defined in 3 different parts: anchor member, recursive member, and final recursive query. So this is we have declared as a anchor member. Now union all is mandatory over here. Whenever you want to use the recursive query or recursive CTE, union all is mandatory. You cannot simply use the union. It will give error, right? Let me show you. Recursive common table expression EMP does not contain a top level union all operator, right? So you have to mandatory use union all. Now how we will define the recursive member? So what I have done over here, I have used the main table over here, main table, and then inner join with this main city, right? Main city. And how does I have done the inner join? I have used the main table manager ID. I will explain you how this query will work in some time. First, I will show you this query. I have used the manager ID of this particular column and then employee ID of this one. So, and over here I have used all of the column and then eh dot employee name as a manager name. And now this query will be over, right? But can you execute this query individually? Can anyone tell me that? Can you execute this query individually? Is it possible?
No.
Yes, right. It is not possible because this is a city we have used in this query, right? So now in the outer query only we can use that one. So now let me show you this result, then I will show you explain how this will work. So this is the result set. So now, okay. Now let me show you how this work. So this is, so suppose you have to consider this is our main table, right? First table. So you can say that this is a table. You can say that this is a E1. You can say that E1, and this is, you can say that E2, right? Now in the first part we have used the where manager ID is null. So this first row it has written, right? First row it has written. Now in the second time when it will go in the second row, so it will check over here. In the next time it will go with to the second row, right? Because level plus 1. So now when it will go to the second row, it will check what is the manager ID of this one. What is the manager ID of this one? So manager ID of this one is 1, right? So now in this table, what is the employee name of this that particular employee ID? So it will compare manager ID column of this table with employee ID column of this table. So now in the second row, when it will go to the second row, what will be the, can anyone tell me what will be the level over here? Over here we are writing result, right? This is, we can say that super manager, right? Super manager, let me copy this one. And now level. So what we have done in the level? We have done in the level plus 1 every time, right? Level plus 1. So what will be the level over here?
So
No, no, level plus 1. In the first row, level is 1, right? So 1 plus 1, it will be 2, right? In the 1, it will be 2, only 1, right? You are getting the things, right?
Yes, yes.
yes, yes.
Okay, now what will be the manager of this one? Because it will check the manager ID column of this particular table. So what is the manager ID of Harshit? Manager ID of Harshit is 1, right? Now it will go to the second table in the this table, and it will check where is 1 is there in the employee ID column. So it is 1 is over here, right? So now it will pick up this employee name because we have mentioned over here eh dot employee name over here, right? This is, you can say that this is emp table. Sorry. And this is, you can say that this table. Okay, now this will be the manager of this one, right? Now when it goes to the third row, when it goes to the third row, let me show you the result again. Okay, now when it goes to the third row, so again it will check the manager ID, right? Again it will check the manager ID. So what is the manager ID of this one? Again it is 1, right? So again, now again it will go to the next table. You have to understand like this only. Again it will go to the next table. It will check where is the employee ID 1. So it is over here, right? So again this is the manager of this employee. And level it will be copy the same because it these two, both of this employees manager is same, right? Both of this employee manager is same. You can see in the employee manager ID column. Now what will be the manager of this one and what will be the manager of this one? Can anyone tell that?
3 and 4.
Sorry.
3 and 4.
Okay, 3 and 4. Okay, so we have to check in this table, right? So what will be the 3? Sorry, sorry. Okay, can what? Who is the manager of this? Can anyone tell?
Its manager name is, I guess, Harshit.
Okay, how? How?
Its manager ID is 2.
Okay, manager ID is 2. Okay,
The employee ID is 2 for Harshit.
okay, right, correct. And for this one,
Um, for this one, I think Hema. That's employee ID is 3.
yes, right, correct. So this is recursive city. Can anyone tell me how? What is the second way we can achieve the same result? What is the second different way we will achieve the same result? For now, you can ignore this column. You can ignore this level column. But I want what I want is I want same thing. Employee ID, employee name, manager ID, and manager name. These four column I want. But what is the second way?
I think we can use joins by combining both tables with such.
Okay, can you help me to write the query? We can use join, right? So let me do this one. Select star from this now.
Again, same joins with the same employee,
Okay, inner join same E2 on.
another name.
Okay,
Uh, with the we have to compare given employee ID for another one manager ID.
okay, means over here,
So
what I have to write?
can you like the same condition like here we are checking right even manager ID if it is equals to the E2 employee ID.
Even manager ID and E2 employee ID. No, this will be, I think it is wrong. Have you checked what is the issue? Mm, or it is correct? Okay, it is correct one, right? Correct one. But okay, what is the result set over here? Okay. Now, can you tell me what is the problem over here?
I think we missed the first January's ID.
Yeah. So for that, what we can do?
Um,
It is eliminated the first record, right? It is
yeah.
eliminated the first record. But if we want the first record as well, then what we can do? It's very simple.
Like we
Yes.
can we do like uh,
Okay.
left join.
Yes. In place of inner join, we need to use
Left.
left join, right? Because then only it will not eliminate any of the record. And now if I want over here super manager, then what I can do? In place of null, I want here super manager.
Can
Then
you give condition like where it is null? Mention it
like
employee.
case, right? Case.
Mm.
Or in place of case, you can write is null also, right? Is null. Then you can write over here comma, and then you can write super manager. Then remove the comma and execute this one. It is work, right?
Yes.
Or you can do one more thing. You can let me show you. You can write over here. You can write this one also, college function. So if you write in place of is null, in place of college, then what it will work? It will do the same thing, right? College will function will return the first non null value in the given parameters. So these are all the parameters, right? This is parameter 1, this is parameter 2. So whenever this employee is there, it is null. So in place of null, it will return super manager, right?
Okay. In case if we have another null, in that case also it gives super manager.
Yes, right. In place of uh, the second, but for our result, it will be one value has one employee will be only super manager, right? In our scenario. But if
Yes.
it is another null also it is there, then again it will return the super manager. Suppose I have again the like you can say I have like this select coalesce, you can say null and Hershey, right? Then it will return me Hershey only, right? Whatever the number of null columns are there. Now
Mm.
suppose over here it is like this. Then again it will give me what it will return now.
Yeah.
Which value it will return now? First non-null value, right? First non-null value. This is the first null value, right? This is
Mm.
the first non-null value. So it will return me
Yeah.
second value, right? So this is the use of the college function, you can say. So this is how you can write the recursive CTE, right? The first member will be the anchor member, second will be the recursive member, and third will be the recursive query. So up to here everything is clear, right? I think someone has message. Okay, now let's see the one example of the correlated subquery. So first let me go through the example directly. So we have three different tables: categories table, products table, and sales data table, right? He's already joined. In sales data table, right? So in the categories table, you can say that category ID, category name is there. And in the products table, category ID column is common in above table and this table, right? And in products table and sales data table, product ID column is common, right? Now our requirement is now our the query combines data from the products table and categories table using an inner join. So we want to combine the products table and categories table using the inner join, but meanwhile we want to do the sum of sales. We want to do the sum of sales which is available in the this particular table, right? Sales column is available in the sales data table, and we would want to do the sum of sales for each product. We want to do the sum of sales for each product using a correlated subquery. Using a correlated subquery. So what I have done over here, the first two portion will be the same, right? We want to join the products table and categories table. That is mentioned over here. Products table and categories table using inner join. But now I want to do the sum of sales. So sum of sale. So what I have done over here, I have mentioned over here select sum of sales from this particular table where, so in this particular table you can say product ID column is there, right? Product ID, and which is available in the products table. So what I have done, sum of sales where sd dot product id equal to p dot product id. So where this p is available, p is available in the outer query of this inner query, right? So this is, you can say that inner query, and this is, you can say that outer query. Now, but in the inner query we have used the outer query column, right? This is my outer query tables column, right? To particularly mention the where condition over here, you can say that, right? So now how correlated subquery will work? So let me first show you the result. Okay, let me copy data of all these three tables. Then particularly this one, and then this one. Now let me the result data as well. Okay, so now what we are doing over here, we are doing the sum of sales against each of the product. Sum of sales against each of the product. So product A is there, right? So where is the product A? You have to identify in this particular table, right? Now what is the product ID of this product A? So product ID is one, right? Now you have to go to this particular sales data table. So now where this product ID 1 is available. So it is available in these two rows, right? Sales ID 1 and sales ID 2. Now you have to do the sum of these two values. So it is 1500, right? So that is what showing over here. That is 1500 is showing over here. Now again you need to go to the product B. Now product B is available over here. Now can anyone tell me what is the sales of product 2?
2000.
2000? How? You have to go
With
to this record, right?
product ad, yes.
This record,
Very
and it is over here 2000, right? Now product C. So product C, product ID is 3. So it is 1500, right? And for product D also, product 4, product ID 4, you have to look into this particular table, and that is 2500. But now what is the purpose to use this table? Because we want category name also. We want category name also. So we have used this table to display the category name because it is available in this table only, right? So let me show you how. So now you can understand this definition. A correlated subquery is a subquery that refers to a column of a table that is not in its from clause. Do you get this point? this particular column, where it is, okay, this particular column, this particular column is not available in the from clause of this, right? From clause of sd dot product id is not available in this particular from clause, main from clause. You can say that main query from clause, or you can say that outer query from clause. Now what is the second? The column can be in the projection clause or in the where clause. In general, correlated subqueries diminish the performance. So while considering the performance, correlated subquery is working very slow. Why it is working very slow? Because a SQL correlated subquery is a query which is executed one time for each record written by the outer query. This is the main thing. One time for each record written by the outer query. So how? So this particular query, it will check the product ID of this table and product ID of, sorry, category ID of this table, and it will compare the category ID of this table. Now if the category ID is same, right? If the category ID is same, or you can say that this inner, that is fine, right? But it will check the product ID, because this is the p dot product ID we have mentioned, right? So every time it will loop the outer query and inside the inner query. So first, if the product ID is same, it will match with this product ID, then it will give the result over here. Let me, okay, this is total sales it is giving, right? But for having the total sales, it will have to loop every time into the outer query, and it will check whether the product ID is same for the inner query. Then it will give me the total sales. Again it will loop again for the next row, it will check again the product ID is same. Then it will do the summation of sales into the inner query, and then it will give me the result. So it will run every time. So correlated subquery which is executed one time for each record written by the outer query. It is called correlated. It is correlation between the number of times the subquery is executed with the number of records written by the outer query. So this is where very rarely we are using the correlated subquery, because it is diminish the performance, right? Now can anyone tell me what is the main difference between normal subquery and correlated subquery? Can anyone tell me the main difference between this correlated subquery and main subquery? Sorry, normal subquery.
In normal software, we are taking directly the query from condition. Here it is different as we are using it one of the column.
Sorry, can you please repeat?
In normal software, we are giving it the from condition. Like we are taking that another table and we are taking that some columns from that subquery. But here we are taking it from directly from one of the column here in correlated. It's not
No,
from the
actually, if someone, okay, 1 minute. Yes, you can speak, Bhagat. Okay, The main difference, you can see that can I execute this query individually? Can I execute this query individually?
I think no, because there is no P
Yes,
P
right.
sub
Yes, right. Exactly.
table.
Yes. So in the you can say that if someone asks you what is the main difference in correlated subquery and normal subquery, you can say that in a correlated subquery we cannot execute the inner query in the usually, right? You cannot write the inner, you cannot execute the inner query individually, while in the subquery you can easily execute the inner query individually, right? It will not throw any error. We will see if that example will come in our session. So this is the result set we have seen over here, right, in the Excel file. Okay, 1500, then 2000, 1500 and 25,000, right? That is same over here. And now again I am showing you the second approach. This is the second approach where I am getting the same result. How I have done? This is the same thing we have seen over here above, right? Sum of sales, then partition by product name. So over here product name is unique, right? ABCD private. I have done the partition by product name, and then what I have done, mm, order by category name, right? So it will say I have done the join of all the three table, all the three table I have done the join. Over here also it is doing, we have used the where clause as a correlated subquery, but over here we are doing the directly join of all the three tables, and we are doing the sum of sales only, right? Because we want to do the sum of sales and partition by product name and order by category name. And this all the columns I want, right? Okay, over here I have mentioned the no column, so you can mention this one as a alias, right? As alias sales. Now let me know, is there any doubt in these two query? It is clear, right?
Yes.
Okay, now let me take one of the example of simple window function. Mm, Select star from this particular table. Okay. Now if you see over here, for category 1 and category 2 data is there, product ABCD data are there, right? But now we want to specify rank. We want to specify rank based upon the sales, based upon the sales and partition by category ID. So now can anyone tell me how the data will be showing? Okay, let me copy this data. Okay, I have copied this data. Now let me tell you what will be over here. Over here rank is there. Over here you can say that dense rank is there. Over here you can say that row number is there. Now after showing the query, after showing this query, can anyone tell me what will be the result in all the three columns? We have done the
All
partition by
the
category and order by sales descending.
yes,
Now
all
I'm going to the Excel. Yes.
actually I think all the values are different. So here is rank 2 for category 1000 is 2 and 2000 is 1.
Okay.
Similarly 2 and 1.
2 and 1. Okay.
Yes.
Now over here.
All the values are different, so same rankings will repeat for dense ranking also.
Matlab
2
this
and 1.
this same value, right?
Yeah.
Okay. And in row number.
It's also same, like all are different values, so we can consider.
Yes, right. Perfect. All are different values, so it will give the highest sales in descending order. It will give the rank 1, right? And the second highest it will give the rank 2. And whenever the category is changed, means partition by is changed, then again it will start from 1. And because of over here our values are distinct, right? As you said, our values are distinct, so in rank, dense rank and row number, everywhere it will be work as the same thing only. But whenever the, you can say that whenever, okay, let me try to add something over here. Let me try insert into this particular table values. You can say that product E, right? Then you can say that category 1, and again you can say that 2000. Then I want to add product F, category 2, and mm, let me add these two rows for now. Now can you tell how rank and dense rank and row number will work? Okay, let me, okay. Okay, let me do order by category and comma sales descending. Okay, now you can tell how rank, dense rank and row number will appear.
Sure.
Okay.
Mhm.
Now tell me what will be the value of rank over here.
It is 1,
Okay.
1,
Okay.
it is 3,
Okay.
1, 1, and 3.
Okay. And in dense rank.
1, it is 1, 1, 2,
Okay.
1, 1, 2.
Okay. And in row number.
It is like 1, 2, 3,
1,
2,
2,
3,
3, and
1, 2.
like this, right?
Yeah.
Okay. Let me execute this query now. Perfect. It is giving the same result. So whenever the rank is there, it will skip the whenever the similar values are there, after the next value, if it will skip the one next row, and it will generate the next to next value in case of rank. But in dense rank, it will give us the continuous next ranking only, and row number is totally different, right? It will uniquely generate the sequential value only. It will not check whether the value are same or not. Row number will not check that one, right? Even though 2000 2000 it is repeating, it is giving the row number 1 and 2 only, not 1 1, right? So it is clear, right? So we may take the next class tomorrow. Remaining, what are the remaining parts are there, that will we will be taking tomorrow, because it will again take maybe half an hour or 1 hour more. So we will see that thing tomorrow. You can ask any question if you have.